As we noticed when we did the exploring exponents activity, there are a number of rules that need to be applied whenever we are simplifying expressions with exponents. And several of those rules are ones that involve products or multiplication. So what we're going to do in this first lesson is we're going to focus on only the ones that involve products, have them here in your notes, and so that you can refer back to them. We'll look at them algebraically and then also allow you to do some practice ones and examples so that you have everything that you can come back and look at later. All right, so the first one that we're going to look at is called the product of powers property. And that simply says if we have two things that are the same bases, A and A, but they have different exponents, say for instance m and n, and those two things are being multiplied together, what I have to do is simply take that base because it's the same and add my exponents m plus n. All right? So if I have a to the m times a to the n, that's simply a to the m plus n. So in this first example down here, the first one, if I have 7 to the third times 7 to the fifth, I notice that the bases are the same as 7. So that's going to be the same as saying 7 to the 3 plus 5, or 7 to the eighth power. All right, that is 7 to the eighth power. So what I would like you to do is do the remainder of example one's problems here, and then check your answers with mine. All right, so in the second one, hopefully everybody got that it simplifies to 9 to the 11th power. Some people may have said it only 9 to the 10th, so you have to be careful. Whenever you have just a number like this one, it's actually the same as saying 9 to the 1. All right, so make sure you include that whenever you're adding your exponents, so 9 to the 11th. In the third one, everybody needs to take care that it's -5 that is being taken to powers. Once again, this would be to the first power. So we need to keep that -5 in parentheses when we're solving this problem, because this -5 to the sixth power is different than this -5 to the sixth power, because this one right here is actually saying take -1 and multiply it by 5 to the sixth. All right, we'll talk more about that later. This one should be pretty straightforward, a to the seventh. Awesome. Let's move on to the second property. The second property is called the power to a power property, power of a power property, which is simply saying if I have something that's being taken to a power, a to the m, and then that is further being taken to a power, let's say for instance n, then this will simplify to a to the m times n. All right. We also did that in the discovery. So this first one under example number 2 could be simplified like this. We have 2 to the 5 times 3, because it's 2 to the 5th raised to the third power. Because I know that, it's going to be the same as saying 2 to the 15th power. All right. Hopefully everybody got that. So now you can do the rest of the problems in example 2, and then we'll check your answers with mine. All right, so hopefully everybody remembered what we just said above, that because this -6 is in parentheses, I have to keep it in parentheses, so it's going to be -6 to the 2 times 5, or -6 to the 10th power. Keep it in parentheses. The third one, pretty straightforward, x to the 8th. And the next one, you have to recognize what the base is. It is y plus 2 that is being raised to the 6th power, so y plus 2 is my base, and so that's what I have to keep as my base, with my final answer being y plus 2 to the 12th. All right, let's move on to the next page. How can I do that? There we go. The next property is called the power of a product property. We also explored this one through the discovery activity. And that simply says if I have two things that are being multiplied together, A times B, and I'm taking it to some power, M, then I can take that exponent and apply it to each one of these factors such that I have A to the M times b to the m. Notice if it were this, just like in that very last example we did on the previous page, a plus b to the m, these are no longer factors. I cannot take that exponent and apply it to that. That is wrong. A lot of people will make this mistake that saying a plus b to the m is a to the m plus b to the m, but that is wrong. Everybody, make sure that you only apply exponents to factors, not to terms. These are terms, okay? Things that are separated by addition or subtraction are terms, all right? Also, one other thing that I wanted to point out is, and that's right here in this bold here, it says, unless the directions state or write your answers, to write your answers using exponents, when asked to simplify expressions, all numerical values should be evaluated and written in simplest form. Okay, so make sure you are evaluating your exponents as much as you can, all right? Unless it says to write your answer using exponents, all right? So, for instance, this one right here says 2 times 3 to the fifth. I could say that that's the same as saying 2 to the fifth times 3 to the fifth. It doesn't say to keep my answer as exponents, so I need to evaluate those. Everybody can use your calculator or use your head to figure out that 2 to the fifth is 32. 3 to the fifth is 243. Once we have that, then we can continue to evaluate that as being 7,776. Yes, you can have calculators on this to be able to figure these out, but hopefully we'll be giving you numbers that you can do in your head, like the ones below. All right, so now that we've done the first one in example 3, I would like you to do the other 3, making sure that you recognize the difference between the second to the last one and the last one because they are different. Make sure you check your answers with mine. All right, hopefully everybody got that the first one ends up being 81x squared y squared because we are applying that exponent to all the factors. Notice also how I do not say I am distributing that exponent. You do not distribute exponents. You apply exponents to factors. Everybody say that. Apply exponents to factors. That's it. All right? You do not distribute them. All right? This second to the last one, hopefully everybody recognized that the negative 4 was in parentheses. So the negative 4 is what's being squared. So the ultimate answer turns out to be a positive 16k squared. And that's because a negative 4 times a negative 4 is a positive 16. Whereas in the second one, that negative sign is outside the parentheses, which means the whole thing is being multiplied by negative 1, so that exponent of 2 is only being applied to the k and to the positive 4. All right, so it's the same as saying negative 1 times 4 squared times k squared, which is negative 1 times 16 times k squared, which ultimately is negative 16, excuse me, k squared. All right. Hopefully everybody got that. All right. If not, check your work. I mean, double check, revise your work. All right. Let's look at the last examples because the last examples are the most interesting ones. All right. I would like you to attempt the first one and then check your answer with mine. Hopefully everybody got that you're applying that power of 2 to the 2 and to the x third, which ends up being 2 to the second power x to the sixth, because it's power to the power, and then x to the fourth. Ultimately, it turns out to be 4x to the 10th. If you did not get that, revise your work and then start on the second one. Check your answer with mine. All right, hopefully everybody noticed that this 5 is not being taken to any power, but this 5 and the x to the second power is taken to the fourth power. So I'm going to have 5 times 5 to the fourth times x to the eighth, applying that exponent to those two factors, ending up with 5 times 625 x to the eighth, which ultimately is 3125 x to the eighth. All right. Hopefully everybody got that. If not, revise your work, then move on to the third one. Check your answers with mine. All right, hopefully everybody recognized that this negative 10 is in parentheses, so negative 10 is being taken to the second power. Also, this negative 4 is in the parentheses, so the negative 4 is being taken to the third power. So when I apply that second power to those two, it's going to be negative 10 squared times n squared. When I apply that third power to those two factors, it's going to be negative 4 to the power of 3 and n to the ninth. Simplifying, negative 10 squared is a positive 100, whereas negative 4 to the third power is negative 64. And then when I further simplify, I can multiply the numbers together. These two end up being negative 6400, and then these two come to n to the 11th. Hopefully everybody got that. If you did not, revise your work and check your answers with mine. Okay, and then let's try the last one, and then once you finish, check your answer with mine. Excuse me. All right, hopefully everybody recognized that this negative sign is the same as negative 1, and it is not being taken to any exponent, so I can write it as a negative 1. But this negative sign actually is the same as negative 1, but it is being taken to the fifth power, so I need to write it as negative 1 to the fifth power. And then I can also take that fifth power and apply it to the x and apply it to the y and apply it to the z, coming up with x to the fifth, y to the 10th, and z to the 15th. Doing something similar with this other part, it's going to end up being x to the 8th, y to the second, and z to the second. Now I can evaluate this. Negative 1 to the fifth is still being negative 1, and then negative 1 times negative 1 is going to end up being a positive, so that's just going to go away. With the x's, I can look at this. X to the 5 and x to the 8 is going to be x to the 13. Y to the 10 and y to the 2 is going to be y to the 12th. And z to the 15th and z to the 2nd is z to the 17th. So hopefully everybody got that. If not, revise your work to make sure that you know what the correct responses should be. All right. So you should have all that you need to know to be able to do the homework for night that is from the textbook. So enjoy. Bye. Bye.